Let's talk about the future of construction, but more importantly, what is at stake for you, building material players. So, as any proper consultant would do, I'm going to start with a few numbers. So, what is the space of construction in our society? Construction represents 6% of the global GDP. It's 5 to 10% of worldwide employment. It's also 25 to 40% of global carbon emissions. So let me just repeat this one. 25 to 40% of global carbon emissions. It's the largest consumer of raw material, and this is not going to be over anytime soon. There is a $1 trillion annual investment required to close the infrastructure gap. So even if we do productivity improvement in the construction industry, it's not going to lead to decrease in construction. It's going to enable more construction, and it will enable us to close that infrastructure gap. There are 200,000 people who are coming into urban areas every day and need affordable and healthy housing. So I want to ask you a question. If construction is so key in our society, how come that construction sites look like this today? When they looked kind of the same in the 60s, except the picture is in black and white, and almost the same even in the 20s, except maybe the cranes. While there are other industries which have gone through major revolution. They are fully digitalized. And I'm just showing the car manufacturing industry here, but there are lots of them. They went from manual manufacturing to more automation to robots everywhere, and now there is a car coming out of the plant every 40 seconds or 45 seconds. So, could the construction site look more like the car manufacturing sites? Actually, yes. So today, the technologies are mature for construction. They are there, they are ready to be used, and they have already been used in many cases. So from the design and engineering phase to the construction phase to the operation phase of the building, there are technologies which exist and enable more productivity, more efficiency overall the process. So in the design and engineering phase, we have BIM. So we can do 3D collaborative designs of the building, having architects, engineers, and even maybe in the future contractors and building materials manufacturers work together in real time and collaborate through the process. We can optimize the design. We can use predictive analytics to find the best design that meet the user needs. The impact of that is already very massive. So when they've built the Washington Stadium, they've used BIM, and they used the model to keep all the players of the supply chain aware of what was going on. And what we saw is that while the steel structure was erected, there has been less than 100 clarification requests in total between all the stakeholders. Usually on a normal project, on a similar project, there would be more than 10,000. In the construction phase, there are many robots that exist today. There is that Adrian robot that is the bricklaying robot. There are installation robots like the Q-boat. They can go in areas where no human can get to put some insulation, and there are many others. We have exoskeleton now that can be put on workers to help them increase their strengths and perform things that they would not be able to do, that they were not able to do in the past. We have also 3D printers, of course, and we have even some robots which can be led by GPS. So another example is the London Stadium, the Olympic Stadium. After the Olympics, they wanted to add a steel roof on top. So what they did is they prefabbed the steel structures, but then when they wanted to assemble it, they used robots assisted by GPS to help the humans install the roof. And this was an amazing work, which was not possible in the past, so it enables great things also on the construction site. In the operation phase, there are many things that are possible, but what we talk more and more is wireless connected building, being able to monitor the temperature of the room, the lighting, organize the cleaning, structure the maintenance work on the site. So there is a company called Ineri Real Time, Australian company, in the Sydney Barangaroo district. For one of their buildings, they built a full virtual building management system to organize all that with dashboards. And the great thing that I love about this is that when there's a maintenance job that has to be done, they can know exactly where the technician has to go, but they also have a virtual idea of how high this is, where it's located, so that the guy who has to go there, he makes sure that he has the right equipment, he has the right ladder to access the place, and it saves times, it brings more efficiency. And I'm just giving a few examples, but we see more and more of these examples coming up. There are more and more projects which use part of these technologies that exist. And the impact of that is really huge. So I want to share this example, which I find quite striking. So BSB is a Chinese company. They've built a 57-story building, skyscraper. They installed it in 19 days. There is a 220-story building that they've installed in 3 months. And they're not the only one. There are things with Vinci, what they do in France with the Primavera. They're doing the same thing, building some student campuses. So how do they do that? Basically, they apply manufacturing best practices to construction. So they've shifted 90% of the construction work off-site in the plant to pre-assemble the parts. So the steel structure, they made as prefabs, but they also included the tubes, the cable, the wires, everything was already there. So that once they came to the building the structure, they were that efficient. There are other examples, of course. So another example that I can give you is the Leadenhall building in London. They shifted 83% of the work off-site. And they even shipped the glass blazing panels from China, which would not have been conceivable in the past. And more broadly, there's BCG study that has been done 1.5 years, 2 years ago, that Stefan mentioned already, where we assessed the gains that we can get with the technologies. And we have assessed that for office building, there can be up to 15% cost saving and 30% reduction in construction time when using those technologies. So minus 12% cost in construction and a big part in operations, assessed to minus 18%. And this was 2 years ago, so probably if we redo the study in 1 or 2 years, it will even be more. In long-distance highway, we have assessed that there could be 16% cost reduction, 20% reduction in construction time. And in a power plant, what we assessed was more 12% cost reduction, 15% reduction in construction time. What is very interesting is that there could be a lot of cost reduction in the design and engineering phase, minus 5% using those technologies. More and more people are conscious that there is a lot of money at stake, that things can really change. But what is kind of worrying is that many startups from the Silicon Valley, who has never worked in construction, start to realize that. And they're not just contemplating it, they're doing real things, they're investing, and they're making business out of it. So if your companies, if you don't do it, others will do it for you, before you. So I'm going to share a few examples of good startups that we like. There is Catera. So Catera is a Silicon Valley. They are 2 years old, and they're worth $1 billion. Last year, they had $500 million of bookings. So what do? Again, they think of other industries, and they try to apply that to construction. So basically, they're relying on prefab, again. So they have built a library of parts. So for example, there are floor panels or exterior walls, so whole parts. And they work always with the same parts, but they don't present pre-made design to the customer. They try to understand their needs, and then they assemble those parts to make to design the building for their client. And the great thing about doing that is that they're working with these parts that they know, and they integrate the supply chain. They know exactly how to supply those parts, so that they can optimize the way the whole project is being delivered to their clients. And I forgot what I wanted to say. Okay, it doesn't matter. So they're really bringing a very good customer service to their clients. There are other startups. There is one called Adidas. They're doing kind of the same thing, but they have added data analytics on top. So they have a set of prefab parts. The customer will choose a set of boundary conditions. Oh, I don't want my project to cost me more than that. I want that room to be close to this one. I want the energy bill to be not more than that, and so on and so forth. They run analytics, test some designs to find the best design that fits the customer need. So they automate design. What they think about when they do that is the customer experience of building a building is really bad. So how can I make that experience really nice? And this is how they start thinking about their business, and they really make revolution happen. There are other startups like the 3D printing startups. Many of you, I guess, are familiar with these. I'm going to mention a few of them. So Winsoon is that Chinese startup. They're very famous. They make the front page all the time. They can 3D print 6-story buildings. They're also famous because they won a $1 billion contract with Saudi Arabia to build a full city. And they can print 10 houses in one day. They're not the only one. There are many other companies looking into the field. There is Vinci, which is working with a startup called X3E. They're looking at making really larger scale buildings and integrating the full supply chain. They work with LafargeHolcim, ABB, and Siemens, and Dassault Systèmes, sorry. There are other companies. There is a company which is called BAM. They have what they call the Freedom 3D printer. So it can move autonomously on the site to go and 3D print something. There is a Russian startup which is called AP Score. What they do is they 3D print the structure, but they also add the paint, which is quite amazing. And there is a last one that I want to mention, which is MX3D. They're able to 3D print steel structures. So they have already been able to 3D print some steel bridges of a small scale. And the last thing that I want to share is there are guys like Elon Musk who have already revolutionized other industries with Tesla in the car manufacturing or with SpaceX in the aerospace. They are looking at construction. So this guy is driving his car saying, oh gosh, I hate traffic. I'm fed up with traffic. So I want to change things. And then he is starting to invest and build boring tunnels and looking at the Hyperloop. So BIM is the centerpiece to make all that happen. If building material players don't start doing 3D objects and making this, the rest cannot happen, so it's a prerequisite. And I'm not going into details because you will hear a lot about it. But usually when we say that to people, they say, yes, of course, makes sense. But me, as a building material player, what is the value for me? It's very annoying. I have to build 3D objects of all my components. It costs me money. My engineering teams, they already have a lot of work. I don't have time. So what is at stake for me? And the second question that they say is, oh, but this is coming in 5, 10 years. Don't I have time? Well, three points to my answer. The first thing is you don't have a choice. Governments are enforcing BIM everywhere in the world. It's coming up. Using BIM is in the 5-year plan, construction plan of China. It's already mandatory in many countries. There is a European directive that forces BIM on public projects. The other thing about you don't have a choice is that there are projects like the New Karolinska Hospital. People who did not have 3D objects of their components were not allowed to bid on the project. And they even requested to have environmental properties in the BIMobject, which also shows how important it is to go in that direction, not making just very basic BIMobjects with physical properties, but really going beyond. So you don't have a choice, and you can already get a lot of money out of it. So 5 points that we have identified. We spoke with 40 people in the industry, and we asked them what are the best things that you do with BIM to get value out of it. And this is what we came up with. And we have a full report written on that. But the first thing is, if there is such a high share of production that is shifted, it is being shifted outside of the construction site, why don't you become the player who is actually prefabricating these components and capture the value add for you, for your company? So making pre-assembled components or making the materials which are being used for additive manufacturing. The second point is you can better promote the innovation that you have in your products. So if you are able to showcase not just the technical properties, but also the environmental properties, the full cost of ownership of your product, it's an opportunity to show the real value of your objects. And we have seen players, I'm not going to reveal who they are, who are already doing that, and they are selling a lot of components, very high value-added components. The third point is if you integrate with your supply chain, you can optimize the whole way you deliver your products, reducing your stocks and optimizing your manufacturing process. The fourth point, and this is why BIMobject was very famous at the beginning, is smart sales and marketing. Because if you know who is downloading your objects, you can do smart marketing. It can generate leads. And there are players out there who generate leads, who have integrated the downloads of the objects with their marketing team to make sure that they know exactly who is downloading their object, and they will make sure that they're going to buy their own. The last thing is smart research and development. So with data, there are lots of things that we can do. And because there is so much things which are becoming digital, if you get that data, you can run analytics to understand the way your customers behave. And you can be smarter in the way you design your next product, making sure that you focus on the right thing that people are looking at. It's also an opportunity, and we see that in the near future. That's not something that we've seen already. But if the BIM environment becomes very collaborative, it can be an opportunity to co-design directly your products with the architects and the engineers in an early phase of the project. So you don't have a choice. There is huge value. And the last thing is, if you don't do it, someone else is going to do it for you. So I'm going to end with a story. So 3 years ago, we spoke to the CEO of a very large contracting firm. And we were looking at that project, which had been done with BIM. And he was like, oh, this is awesome. I love it. And BIM is going to be huge for very innovative, very complex projects. I'm sure of it. I'm not sure it's going to go down to all the types of projects. We spoke to him 6 months ago when doing the study. And what he said was, I'm sure all the projects will be designed with BIM in the future. And the whole supply chain is going to be using only this. And it will be fully integrated. I'm 100% sure. What I'm not sure is when. We don't know when it's going to happen. At BCG, we keep having those discussions around this. We think it's getting closer. We feel it's getting closer, probably 5 to 10 years is what we have in mind right now. The thing is, when it comes, you don't want to be the guy who's missed the revolution. You don't want to be the Kodak of tomorrow. And as big companies usually think that they're very resilient to these changes, it's true. Bigger players are more resilient. But there are medium-sized, small-sized players in Europe and in other countries who will be less resilient, and they will suffer. And then they can be purchased by really big Chinese companies who are very innovative, and then your home market can be at risk. Thank you.